Hello, welcome back from break. All right, today we are in class. We were writing and graphing inequalities. And remember, inequalities are those four types of symbols: less than, greater than, less than or equal to, or greater than or equal to. And in this video, instead of writing and graphing inequalities, this part, we're going to cross that off, and we are going to solve and graph inequalities. So you're already be given an inequality statement, and you're going to need to solve it and then graph the solutions. We're going to look at two of them. So let's look at example 1. So if you need to pause the video to write this down, we have a variable m minus 2. So if we take a number and we subtract 2, it's always greater than or equal to the number -6. Okay, so that's me just reading it. What we're trying to do is figure out for what values of m will this inequality statement be true. So if you were guessing and checking and you just guess and you're like, well, could m be 1? Well, if you plug in 1 for m and you subtract 2, will that be greater than or equal to -6? So we're making this a question, and we are questioning whether it'll be greater than or equal to -6. Well, 1 minus 2 is -1, and is that greater than or equal to -6? Yes! Yes, it works! So is our answer m equals 1? Well, should we try any other number to see if it works? If we already found one that works? Well, the thing is, if I try 2 for m, look at this. If I take 2 minus 2, that's 0. Is that greater than or equal to -6? Yes! So m could be 1, and it could be 2. So what you need to notice with inequalities compared to equations is that inequalities gives us more than one answer. We're going to get an infinite number of solutions. So instead of guessing and checking at where the heck it starts and what the solutions are, because that'll take forever, you would solve like you're used to with an equation. So I'm going to put a line down here. The only difference is that we have an inequality instead of an equal sign. So now to get m alone, I need to get rid of this subtraction by 2. So how do I get rid of a subtraction by 2? Well, I would add 2. So what do I do with the -6? I do the same thing that I did there, add 2. So now my m will be alone. These are opposites. That is 0. So m, if I add these together, which one of them's negative, one of them's positive, on the number line, where am I going? From 0, I go left. Add 2, I'm coming back. So really, I'm subtracting them, and my answer is still going to be negative, so -4. Thing is, this is not equals anymore. Remember, we have more than one answer. We have an infinite number of solutions. We have to use the inequality that was used above. So any value for m that is greater than or equal to -4 should make this inequality statement true. So let's go ahead and plot our solutions. So if we look at our solution statement, -4 is the special number. If I go 1 to the right, that means it's getting warmer, so I'm at -3. 1 to the left, I'm getting colder, -5. I'm going to put a dot at -4, and it's going to be closed. The reason why it's closed is because I am looking at the inequality that is being used, and there is an equals with it. So it can equal -4, so it's going to be a closed dot. Then I'm going to shade. I'm going to either shade to the left or the right. It says my solutions m are greater than or equal to -4. So which side have numbers that are greater than -4? Well, -3 is greater, and so is 0 that exists over here, so is 10 that exists over here, so is 100 that exists over here on this side. So I'm going to shade to the right to say those are the solutions. Anything you pick on this side will end up working in this original inequality statement. I said we were going to do 2 examples, so here's the second one. So now you're given a statement and we need to solve it. and graph it. So again, just like before, I'm going to solve it the same way as an equation. I'm going to rewrite d plus 9. I need to get d alone. To do that, I need to get rid of the plus 9. So I'm going to do the inverse operation of addition, which is subtraction, by that number I want to go away, which is 9. And then what do I do with the 8? I do that same thing that I just did here to this side, subtract 9. So now these are opposites. That is 0. That is why we are left with just d on the left. And then 8 minus 9 is negative 1. And now it doesn't just equal negative 1. Because we're working with an inequality, our solutions will have to be less than negative 1 to make this inequality statement true. So now when I graph it on my number line, if I look at my solution statement, negative 1 is the special number. If I go to the right and get warmer, 0. If I go to the left and get colder, negative 2. And then at my special number of negative 1, I am this time going to use an open dot because there is no equals with it. So my solutions start there, but negative 1 is not going to end up making the original inequality true. And then the solutions need to be less than negative 1. So is 0 less than negative 1? No. So I don't shade that direction. Negative 2 is less, and so are the numbers that exist to the left of that. And so is negative 1.5. Okay, these are all solutions. And when I plug it into the original inequality statement, we'll make it true. So what we just did in this video is solve and graph inequalities. And hopefully you wrote that in your math notebook that I will have you open up in class tomorrow during the warm-up so I can come around and see that you have that in there and you have written this solve and graph inequalities in your table of contents. All right, see you in class tomorrow. Enjoy the evening or morning.